Welcome to Introduction to Hypothesis Testing for a Proportion. In this section, you will learn to test a population proportion. Hypothesis tests for proportions are used when politicians want to know the proportion of their constituents who favor a certain bill, or when a quality assurance engineer tests the proportion of parts that are defective. We have to make sure n times p is greater than or equal to 5, and n times q is greater than or equal to 5 for a binomial distribution. Then the sampling distribution for p hat is approximately normal with a mean equal to p and a standard error of the square root of p times q divided by n. So these are the steps. First, we're going to write the claim mathematically stating HO and HA. Now remember, when we're stating these, HO always contains equality. So it's going to have less than or equal to, greater than or equal to. And HA is always going to have the symbols less than, greater than, or not equal to. So make sure you choose which one has the claim. Step number 2, the null hypothesis. Okay, the null hypothesis to assume the population proportion. So remember how we do this, where we then assume the population proportion. So this H sub 0, we're going to assume the population proportion. P equals some number that's claimed. Use the alternative hypothesis to determine if it's a left, right, or two-tailed. And so remember, if it's a left tail, it's going to be a less than symbol. If it's a right tail, greater than symbol. And if it's two-tailed, it's going to be a not equal to symbol in the HA. Next we need to state the rejection criteria. And the rejection criteria, we're going to focus on the p-value method. So the rejection criteria is we're going to reject the null hypothesis if the p-value is less than or equal to our significance level. And remember, our significance level might be alpha equals 0.05, 0.01, or 0.10. Those are the three most common ones. Next, number 4, we have to calculate the test statistic using technology or the formula. Okay, so this is our test statistic. Remember, p hat is going to be our sample proportion. P is going to be our population or our claimed proportion, our claimed population proportion. Q, remember, is going to be 1 minus p, and n is going to be our sample size. Next, we have to determine the p-value using technology or a chart. Okay, so make sure you know how to use either StatCrunch, your calculator, or some other sort of technology. Next, we have to make a decision whether we reject the null or fail to reject the null. So making a decision. So when we're making our decision, remember, we're going to make a decision. So we're going to reject the null hypothesis if, remember, our p-value is less than or equal to our significance level. It kind of comes back to number 3. So number 3 and number 6 here, they kind of go together. And then number 7, we're going to interpret the decision in context of the original claim. So we're going to have some different options. Remember, we're going to have either does reject, we're going to have does not reject, we're going to have does support, and we're going to have does not support. And you can look at that on various charts. Another important thing that you might want to do is have your steps for hypothesis test ready. It has a lot of this more in detail. I'll show it to you. These are our steps for hypothesis testing. You can see step 1 about the claim, the null, the alternative hypothesis. Step 2 about the null hypothesis for the assumption and the tail. Step 3 is the rejection criteria. Step 4 is the formulas for the test statistic. Step 5 is calculating the p-value with the StatCrunch instructions. And then step 6 is how to recognize when to reject or fail to reject the null using the p-value. And again, the flow chart of whether you do reject, you do not reject, you do support, or do not support. So you can use those as well.